Alright, you guys, if you guys could please turn to the page in your notes that looks like this. Unit 1, Essentials of Geometry. I'm going to start off by giving you guys some definitions. In geometry, the words point, line, and plane are undefined terms. Basically, these words do not have formal definitions, but there is an agreement about what they mean. For example, a point, it has no dimension, and it is represented by a dot. Okay, and if I were to name this, I would call it point A, or if it was some other letter, I would call it point, whatever letter it was. A line has one dimension. It is represented by a line with two arrows, or two arrowheads, but it extends without end. So when you look at this, I want you to imagine that this actually extends forever in this direction and forever in that direction. It is infinitely long in both directions. Through any 2 points, there is exactly one line. So you can use any 2 points on a line to name it. You could call it line AB or line BA. Or in this case, if there's a letter off to the side like this, you can also call it line L. A plane has 2 dimensions. It is represented by a shape that looks kind of like a floor or a wall, but this also extends without end. So I want you to imagine that this way, that way, it extends infinitely in all directions, but it's flat. Okay? Through any 3 points, not on the same line, there is exactly one plane. You can use 3 points that are not all on the same line to name a plane. So you could name it plane ABC, or plane CBA, or BAC, or any combination of these 3 letters. Or if there were other letters in the plane, you could name them after those. Or if there's a letter in the corner, like here, you could just call it plane M. Okay? In geometry, terms that can be described using known words such as point or line, these are called defined terms. Segment and ray are defined terms. A segment, the line segment AB, or segment AB, written like this or like this, consists of endpoints A and B, and all points on line A and B that are between points A and B. Okay? Note that you could order the letters this way or that way. The ray AB consists of the endpoint A and all the points on line AB that lie on the same side of A as B. Now, with segments, you can reorder the letters like this, but with rays, it is very important that the arrow is over the correct letter. So if you wrote this as ray BA, that would be incorrect. Okay? That would be a different ray. Collinear points are points that lie on the same line. So in this diagram, points A, B, and C would be collinear. Coplanar points are points that lie in the same plane. So in this diagram, points A, B, and C would all be coplanar. If C lies on line AB between A and B, then CA and CB, rays CA and rays CA and CB are opposite rays. Okay? Also something to keep in mind, segments and rays are collinear if they lie on the same line. So opposite rays going opposite directions like this one, these would be collinear. Also, lines, segments, and rays are coplanar if they lie on the same plane. So coplanar stuff, it doesn't have to be just points. You could have lines and other stuff that are coplanar. Alright, angles. An angle consists of 2 different rays with the same endpoint. The rays are the sides, and the endpoint is called the vertex of the angle. Okay? There are different ways you can name this angle. The angle shown here can be named angle BAC, angle CAB, or just angle A. Remember this little symbol here. This is an important symbol. Anytime you see that symbol, it means angle. Okay? An angle is measured in units called degrees. That's what this little circle means. Okay, so this would be 0 degrees. This would be 90 degrees. The M in front of the angle indicates measure. So what this says is the measure of angle A. So what this is saying is the measure of angle A is in between 0 and 90 degrees. angles can be classified as acute, obtuse, right, or straight. An acute angle is going to be in between 0 and 90 degrees. An obtuse angle is going to be between 90 and 180 degrees. A right angle is going to be exactly 90 degrees, and a straight angle is going to be exactly 180 degrees, or a straight line. Okay? All right, the midpoint formula. You can use the coordinates of the endpoints of a segment to find the coordinates of the midpoint. Whoops, I forgot the M. I'll get that. There we go. Okay. The coordinates of a midpoint of a segment are the averages of the x-coordinates and the y-coordinates of the endpoints. Okay, so hopefully you guys remember that when you take the average of two numbers, you add them together and divide by 2. So the midpoint is just going to be the average of the x's and the average of the y's. Okay. The distance formula is a formula for computing the distance between 2 points on a coordinate plane, or the length of a segment between 2 points. Okay, so for example, if A and B are points in a coordinate plane, then the distance between A and B would be found with this equation here. Now, some of you guys might remember the Pythagorean theorem from junior high. If you don't, that's okay. We're going to be learning it this year too. But you'll actually find that this is essentially the Pythagorean theorem, just written out with a bunch of different variables. This would be A squared, this would be B squared, and this would be C squared. And then in order to find C squared, or in order to get rid of the squared on the C, you would take the square root at the end. Okay, we'll talk a little bit more about that when we go over it in class. All right, the segment addition postulate. If you have a segment, and let's say in this case B is in between A and C, then AB, where's my little cursor? Then AB, that's this distance here, plus BC, that's this distance here, equals AC, that's the whole thing. So if this was 2 inches, or we'll say this is 6 inches long, and this is 2 inches long, then the whole thing has to be 8 inches long, because 6 plus 2 is 8. Okay? A midpoint, or segment bisector, the midpoint of a segment is the point that divides the segment in half. It divides it into 2 congruent segments. I keep losing my cursor here. Where is it? There it is. Okay. So this little red dash here indicates that this is congruent. Congruent means equal to this over here. So if I said this whole thing was 10 centimeters, and this is the midpoint, then the midpoint divides it into 5 and 5. Okay? A segment bisector is similar to a midpoint, except that it could be a point, a ray, I drew a line here, it could be a line segment or a plane, anything that intersects the segment at its midpoint. Okay? A midpoint or a segment bisector bisects a segment. Bisect means to cut in half. Okay? So, if it cuts in half here, in both cases we have segment AM is congruent. Remember this symbol here. This little symbol means congruent. Segment AM is congruent to segment MB. Okay? If you're going to write that two segments are congruent, you're going to draw a little segment over the name of this, over the name of the segment that you're talking about. Okay? If you're just saying that they're equal, you don't have to draw the line overhead. The angle addition postulate is a lot like the segment addition postulate. Okay? If P is in the interior of angle RST, then the measure of angle RST is equal to the sum of the measures of angle RSP and angle PST. Okay, so for example, if this was, I don't know, 40 degrees, if this angle here was 40 degrees, and this angle here was 30 degrees, then the whole angle would be 70 degrees, because 40 plus 30 is 70. Okay, so it's pretty much exactly like the segment addition postulate, but with angles. an angle bisector is pretty much the same thing as a midpoint or a segment bisector. Okay? A couple things here. If you notice, where's my cursor again? There it is. Okay. If you notice, you see this little dash here? That means that this angle is congruent or equal to this angle here. So the way you would write that is angle RSP is congruent, there's that symbol again, to angle PST. Or you could write it, the measure of angle RSP is equal to the measure of angle PST. Two angles are complementary angles if the sum of their measures is 90 degrees. Okay? Remember, this little box indicates that the angle is a right angle, and a right angle is 90 degrees. Okay? Each angle is the complement of the other if they're complementary angles. Two angles are supplementary angles if the sum of their measures is 180 degrees. Each angle is the supplement of the other. Okay? Complementary angles and supplementary angles can be adjacent, meaning attached, kind of like this one here, or this one here, or they could be non-adjacent, like these. So like if this one was 40 degrees and this one was 50 degrees, they're complementary because they add up to 90, but they're not adjacent because they don't share a side. Okay? Same thing over here, these would be non-adjacent. Adjacent angles, once again, are angles that have a common vertex and a common side, but they have no common interior points. Two angles are vertical angles if their sides form two pairs of opposite rays, kind of like here. You see how these lines crisscross? Angles 1 and 2 that are opposite of each other, these would be vertical angles. Also angles 3 and 4. And just a reminder, this little dash means that these two angles are congruent. These have two dashes, so these two angles are congruent. Okay? The vertical angles congruence theorem states that vertical angles are congruent. So in this case, angle 1 is congruent to angle 2, and angle 3 is congruent to angle 4. Two adjacent angles are a linear pair if their non-common sides are opposite rays. So basically, if two angles are adjacent and they come together to make a straight line, they would be a linear pair. The angles in a linear pair are supplementary angles. So, in this case, where's my cursor? Oh. The measure of angle 5 plus the measure of angle 6 equals 180 degrees. The linear pair postulate once again says linear pairs are supplementary. In geometry, a figure that lies in a plane is called a plane figure. A polygon is a closed plane figure that is formed by 3 or more line segments called sides. So in this case, I've got 5 sides enclosing a polygon. Each side intersects exactly 2 sides, one at each endpoint, so that no two sides with a common endpoint are collinear. Kind of like this. So basically the sides are the segments, and each endpoint of a side is called a vertex. So the vertices are the corners. Okay? Oh, vertices is the plural of vertex. Convex and concave. A polygon is convex if no line that contains a side of the polygon contains a point in the interior of the polygon. Another way you could see is if all the vertices are pointing out, it's convex. If you have a vertex that kind of caves in like that, it's concave. Okay? In an equilateral polygon, all the sides are congruent. Remember, this little dash means congruent. So this would be an equilateral polygon. An equiangular polygon, all the angles in the interior are congruent. So this would be an equiangular polygon. A regular polygon is both equilateral and equiangular. All right? All right, let me list out the different kinds of polygons. All right. A triangle has 3 sides. A quadrilateral has 4 sides. A pentagon has 5 sides. A hexagon has 6 sides. A heptagon has 7 sides. An octagon has 8 sides. A nonagon has 9 sides. A decagon has 10 sides. A dodecagon has 12 sides. And an n-gon has n sides. Okay, so for example, a polygon with 14 sides would be called a 14gon. Alright, and that's all the notes for the first unit. Let me know if anything doesn't make sense. Alright?